In the realm of astronomical discoveries, one object has recently exploded in size, leaving scientists scrambling for answers. This object, known as 3I Atlas, has baffled astronomers with its inexplicable behavior, sparking numerous theories and debates about its origins. The question that now looms is whether 3I Atlas is just another anomalous comet, or if it could be something entirely different, perhaps even artificial. The astronomical community has long been familiar with anomalies in space. The history of space exploration is dotted with strange phenomena, from pulsars to fast radio bursts, which initially sparked wild speculation, only to be later explained through natural processes. However, 3I Atlas presents a unique challenge. Its behavior does not neatly fit into any existing categories of known celestial bodies. What makes this object particularly perplexing is its sudden and massive expansion. The size of 3I Atlas has recently been reported to have grown significantly, far exceeding expectations for an object of its type. This sudden expansion, coupled with its peculiar trajectory and the formation of massive jets, has led some scientists to consider the possibility that it may not be a natural phenomenon at all. Before jumping to conclusions, it is important to understand the history of such phenomena in astronomy. Many discoveries have been met with skepticism, and for good reason. The early observations of pulsars, for instance, were initially dismissed as potential signals from extraterrestrial civilizations, nicknamed Little Green Men, LGM, before scientists realized they were rotating neutron stars. Similarly, the first observations of fast radio bursts, which seemed to come from deep space, led to speculation about artificial signals, only for it to later be understood as a natural astrophysical occurrence. These examples serve as a cautionary reminder. Extraordinary claims require extraordinary proof. For 3I Atlas, the challenge lies in proving its nature. Could it be the result of some unknown natural process? Or is there a possibility it's something entirely different? Perhaps a technologically advanced probe sent from another star system? One of the main arguments against the artificial theory is the absence of direct evidence. Speculation about alien technology has been met with criticism, particularly because there are no concrete signs of propulsion or electromagnetic emissions that would suggest an artificial origin. Without such evidence, invoking extraterrestrial technology is premature. Scientists call for the detection of specific signals, such as propellant ions or unambiguous acceleration, that would confirm the presence of artificial propulsion systems. Until such evidence is found, the possibility of 3I Atlas being an alien artifact remains speculative. However, the scientific community is also aware of the limitations of dismissing the hypothesis without testing it thoroughly.
If 3I Atlas behaves in ways that suggest it might be artificial, then it is important to investigate the possibility further. The scientific method encourages rigorous testing, and if the tests reveal inconsistencies with known cometary behavior, such as systematic acceleration or ionized xenon emissions, then the hypothesis of artificial propulsion must be considered seriously. Conversely, if tests show that the object behaves consistently with natural comet physics, the artificial hypothesis can be ruled out. At the heart of the debate lies the rarity of 3I Atlas. If it is a natural object, its size, trajectory, and behavior place it at the extremes of probability distributions, making it an outlier. While rare, such objects can exist in nature. On the other hand, if it is artificial, its rarity could be considered a feature, not a flaw. Technological probes are not bound by natural population models. They can be as large or as small as their creators wish, and they can be designed to follow optimized trajectories that target specific star systems like the one 3I Atlas appears to be doing. This scenario presents a compelling argument for considering the artificial hypothesis, especially when one considers the extraordinary alignment of its orbit, which is nearly aligned with the plane where the Earth and other planets orbit. The crucial question now is, do we explain 3I Atlas by stacking a series of low-probability natural coincidences, or do we consider a single, higher-probability artificial explanation? The answer depends largely on one's perspective on the likelihood of extraterrestrial intelligence. While some scientists believe the galaxy is teeming with advanced civilizations and their probes, others argue that we are alone in the universe. Both camps are speculating, and neither has definitive proof. What makes 3I Atlas significant is that it presents an object we can test rigorously enough to provide a potential answer to the question of extraterrestrial technology. The universe may soon reveal something monumental, but we must be ready to listen to what it tells us, even if the answer is uncomfortable or difficult to accept. The mystery of 3I Atlas has captivated the attention of the astronomical community, and with each new observation, the questions surrounding its nature only deepen. As scientists continue to observe the object, one thing has become clear: 3I Atlas is not behaving like any known comet or interstellar object. Its massive jets stretching across millions of kilometers defy the laws of comet physics that have been established over decades of study. In November of 2025, two amateur astronomers, Frank Nebling and Michael Buchner, captured an image that shocked the scientific world. Using modest equipment, a 140mm telescope and a 6,200mm camera, they observed a structure far beyond anything expected.
The jets extending from 3I Atlas were not only massive in size, but appeared to be three-dimensional and structured in a way that defied typical cometary behavior. These jets extended approximately 950,000 kilometers towards the Sun and 2.85 million kilometers away from it. To put this in perspective, these jets are comparable in size to entire planetary systems. The size and scale of these jets were so extraordinary that they appeared to have come into existence almost instantaneously. This sudden expansion has raised significant questions about the nature of the object. According to standard comet physics, jets are formed when volatile ices, such as water and carbon dioxide, are heated by solar radiation and sublimate, creating gas and dust that is pushed away by radiation pressure and the solar wind. However, 3I Atlas's jets do not conform to this explanation. Instead of dispersing and breaking apart as expected, the jets maintained their structure across vast distances, something that is not possible under normal conditions. In addition to the strange behavior of the jets, there is the matter of 3I Atlas's orbit. The object is on a hyperbolic trajectory, meaning it is not bound to our Sun and will eventually leave the solar system. But what makes this particular orbit puzzling is that it is almost perfectly aligned with the ecliptic plane, the flat disk in which the planets orbit. This is statistically improbable. Most interstellar objects that pass through our solar system do so from random directions across the celestial sphere. The probability of an object entering our system in such a specific orientation is a mere 0.2%, or about 1 in 500. This further complicates the mystery of 3I Atlas. Mass estimates for 3I Atlas also contribute to the growing intrigue. Based on its brightness, scientists estimate that the object has a diameter of at least 5 to 10 kilometers. This makes it significantly larger than previous interstellar visitors, such as Oumuamua, which was only a few hundred meters across. If 3I Atlas is indeed around 10 kilometers in diameter, with a density typical of comets, its mass could be in the tens of billions of tons. This raises further questions, as such a massive object passing through the inner solar system within a single decade is extraordinarily rare, with an occurrence probability of only 1 in 100 million. Harvard astronomer Avi Loeb
known for his willingness to entertain unconventional ideas, has publicly questioned whether 3I Atlas could be something other than a natural object. He suggests that the rapid expansion of the object, along with its strange trajectory and massive jets, might indicate that it is not a comet at all, but something artificially constructed. This idea is controversial, and while many astronomers are still exploring natural explanations, Loeb's suggestion has added fuel to the fire.
The question now is whether this object represents a new frontier in our understanding of space and the objects that inhabit it, or if it is simply an anomaly that can be explained by some yet undiscovered natural phenomenon. The thousand-fold growth of 3I Atlas demands a detailed examination, and whether it is a natural object or something engineered, the answers we uncover could change everything we know about the universe. The mystery surrounding 3I Atlas only deepens as we examine the physics that govern its behavior. To understand the scale of the anomaly, let's delve into how comets typically function and why 3I Atlas does not follow the usual patterns. Comets outgas materials like water, carbon monoxide, and carbon dioxide as they approach the Sun, causing them to develop the familiar tail of gas and dust. This outgassing happens because solar radiation heats the surface of the comet, causing volatile ices to vaporize and escape into space. The typical speed of this outgassing is around 0.4 kilometers per second, a distance is roughly 3 astronomical units from the Sun. For 3I Atlas, however, the jets emanating from its surface reach far beyond what standard cometary physics could explain. The sunward jets reach approximately 950,000 kilometers, and the jets extending away from the Sun measure about 2.85 million kilometers. To give this scale some context, the Sun itself has a diameter of only about 1.4 million kilometers. These jets, as large as planetary systems, should not be able to retain their shape for such vast distances under normal conditions. The solar wind, a constant stream of charged particles emanating from the Sun, moves at speeds of approximately 400 kilometers per second. This creates a tremendous amount of pressure on any material that moves slower than the solar wind, effectively dispersing and eroding it. For 3I Atlas's jets to remain coherent against such a powerful force, the material would need to be incredibly dense, much denser than anything seen in typical comets. Estimates suggest that the density of the material would need to be millions of times greater than that of the surrounding solar wind to maintain the jet structure. This creates an enormous mass flow with billions of tons of material potentially streaming off the nucleus every month. Such a rapid mass loss cannot be sustained indefinitely, especially for an object of 3I Atlas's size. In addition to the remarkable size of the jets, the object's behavior also challenges our understanding of cometary dynamics. A typical comet, as it releases gas, will experience small changes in its trajectory due to the momentum imparted by the outgassing, a phenomenon known as non-gravitational acceleration. This effect is usually minor but measurable, causing the object to slightly alter its orbit as it sheds material.
However, 3I Atlas has shown no significant signs of such non-gravitational acceleration, which would normally be expected if it were expelling massive quantities of gas. This lack of acceleration further complicates the notion that 3I Atlas is simply a highly active comet. Adding to the enigma are the anti-tail jets, which point directly toward the Sun, an unusual phenomenon. Typically, jets from a comet are directed away from the Sun by radiation pressure and solar wind. The anti-tail jets, however, appear to contradict this principle. One explanation for this could be that the object is experiencing some form of electromagnetic influence, such as charged dust particles interacting with the Sun's magnetic field. While this effect has been observed on smaller scales around comets, it has not been seen operating on the massive scale observed in 3I Atlas. Additionally, if these jets were simply a projection effect, they should not persist over long periods as we have observed with 3I Atlas. The combination of these unusual physical characteristics, massive, columnated jets, the lack of expected acceleration, and the appearance of anti-tail jets, suggests that 3I Atlas is not behaving according to known cometary physics. One possible explanation is that the object is not a comet at all, but something else entirely. Could it be a probe or spacecraft designed to function in ways that go beyond our current understanding of natural objects? The potential for 3I Atlas to be an artificial object has spurred considerable debate. Some astronomers argue that the observations, while extraordinary, could still be explained by an extreme yet natural cometary mechanism. Others suggest that the object's size, trajectory, and behavior are too anomalous to be explained by any known natural processes and may indicate artificial origins. The debate is complicated further by the rarity of such an object. Based on population models, large interstellar objects like 3I Atlas should be extraordinarily rare. The probability of encountering such an object in our solar system within a decade is as low as 1 in 100 million. Despite the controversy, the data so far suggest that 3I Atlas is no ordinary comet. Whether it is a highly unusual natural phenomenon or an artificial object remains to be seen. However, what is certain is that this object is pushing the limits of our understanding of space and the forces at play within it. As we move further into the mystery of 3I Atlas, another layer of complexity emerges when we consider its mass, rarity, and trajectory. To better understand why this object is such an anomaly, we need to explore how astronomers estimate the population of interstellar objects like 3I Atlas.
For decades, astronomers have been trying to estimate the number of rogue objects that drift through interstellar space, and these calculations are based on a variety of factors: how often we detect interstellar visitors, the sensitivity of our telescopes, and how much of the sky we are actually observing. From these observations, scientists have developed models to predict the density and size distribution of interstellar objects. The models consistently suggest that small objects vastly outnumber larger ones. For instance, for every object that is about 10 kilometers in size, there should be thousands that are 1 kilometer in size, millions that are hundreds of meters, and billions that are only 10 meters across. This distribution follows a power law similar to what we observe in our own solar system, such as in the asteroid belt and the Kuiper belt. When astronomers detected Oumuamua, a small interstellar object only a few hundred meters in size, the model predicted that such objects should pass through the inner solar system roughly once every year or two. Similarly, the detection of 2I Borisov, a comet-like object roughly 1 kilometer in size, also aligned with predictions. However, 3I Atlas is different. If it truly has a diameter of 5 to 10 kilometers, or possibly even larger, it is at the far end of the size distribution, representing an object much rarer than anything previously encountered. To put this in perspective, if 3I Atlas is truly 10 kilometers across, the likelihood of encountering such a large object in our solar system within a decade is extraordinarily low, somewhere between 1 in 10 million and 1 in 100 million. Given that we have only been systematically searching for interstellar objects since 2017, the odds of finding something this large in such a short time frame are astonishingly slim. Yet here it is, barely 8 years into our search. This rarity is made even more striking by the object's trajectory. The orbit of 3I Atlas is nearly perfectly aligned with the ecliptic plane, the flat disk in which the planets of our solar system orbit. For context, interstellar objects typically arrive from random directions across the entire celestial sphere. If you imagine the solar system as a dinner plate, interstellar objects should ideally approach from above, below, or around the edges of the plate in all directions. The probability that a random interstellar object happens to arrive within 5 degrees of the ecliptic plane is only about 0.2%, or 1 in 500. So the probability of 3I Atlas arriving with such a precise alignment with the plane where Earth and the other planets orbit is exceptionally rare. If we combine the probability of the object's size and trajectory, we arrive at a combined likelihood that is practically astronomical.
When we factor in the size, an object potentially 5 to 10 kilometers in diameter, and its highly specific trajectory aligned with the ecliptic, the combined odds approach 1 in a few billion.
If you were to run the solar system's history forward for billions of years, with interstellar objects passing through at random intervals and random orientations, encountering something like 3I Atlas would be a once-in-a-lifetime event, if that. Yet here we are, only 8 years into our active search for such objects, and 3I Atlas has already appeared. This rare combination of size and trajectory has sparked heated debates in the astronomical community. Some scientists suggest that our detection of such a massive object could be the result of a selection bias. Perhaps larger objects are simply easier to detect, which has skewed our senses of interstellar objects. However, the rarity of this object's characteristics still raises significant questions. If objects of this size and orientation are more common than models predict, then our understanding of the density and behavior of interstellar objects may be fundamentally wrong. Such a discovery could revolutionize our understanding of planetary formation, system ejection mechanisms, and the dynamics of interstellar space. But this leads us to an uncomfortable thought. If 3I Atlas is not a natural object, the rarity of its size and trajectory might no longer be a statistical anomaly. It might be a feature. If the object is artificial, it could have been deliberately designed to fit these parameters. This shift in thinking moves us from the realm of natural explanations into the domain of extraterrestrial technology. One possibility that arises from this new line of reasoning is that 3I Atlas could be an artificial probe or spacecraft deliberately navigating through the solar system to observe it. If this is the case, the trajectory, the size, and the highly structured jets could all be the result of advanced propulsion technology. The near-perfect alignment with the ecliptic could suggest that the object was specifically targeted to pass through the solar system in a manner that would allow it to survey planets and potentially gather information about life. This brings us to the core of the debate. If 3I Atlas is indeed an artificial object, how does that change everything we know about the universe? If 3I Atlas is indeed an artificial object, the implications for science and our understanding of the universe would be profound. The idea that we might have detected an extraterrestrial probe, a visitor from another star system, challenges our entire framework for thinking about space exploration and the search for intelligent life beyond Earth. It raises a host of questions about the nature of such civilizations, their technologies, and their motivations. If we are truly witnessing the remnants of a spacecraft, it would not only represent the first solid evidence of extraterrestrial intelligence, but also offer us a unique opportunity to study a foreign technology up close. However, before jumping to conclusions, we must consider the evidence carefully.
While the trajectory and the unusual behavior of 3I Atlas might seem to suggest an artificial origin, it's important to remember that extraordinary claims require extraordinary evidence. We cannot dismiss the possibility of natural explanations just because the object behaves in ways we don't fully understand. After all, nature has a way of surprising us in ways that can be just as strange, if not stranger, than anything we can imagine. To this end, astronomers are continuing their efforts to gather more data and test the various hypotheses surrounding 3I Atlas. Over the coming months, as the object moves further away from the Sun and fades from view, we will have a limited window of time to make definitive observations. The results of these observations will be crucial in determining whether 3I Atlas is a natural object with extremely unusual properties, or whether it is, in fact, something engineered by an advanced civilization. One of the key areas of focus for astronomers will be spectroscopy. This technique allows us to analyze the light emitted by the object and break it down into its constituent wavelengths. By identifying the chemical composition of 3I Atlas, we can compare it to what we expect from natural comets. If we find unusual elements or molecules that are not typically seen in comets, this could be an indication that the object is artificial. Additionally, the analysis of isotopic ratios could provide further clues about the object's origin and history. Another important test will be to track the object's movement over time. Comets experience subtle changes in their trajectories due to the outgassing of material from their surfaces. This causes them to experience a weak rocket effect as the expelled material pushes the object in the opposite direction. By tracking these small deviations in 3I Atlas's orbit, we can gather more information about its composition and behavior. If the object shows no such changes, it could point to the absence of any natural outgassing, or the presence of a propulsion system instead. Furthermore, time series imaging, which involves capturing multiple images of the object over time, will be crucial in studying the behavior of the jets. By observing how the jets evolve and change, we can determine whether they are the result of normal cometary outgassing or something more complex, such as exhaust from an artificial propulsion system. If the jets remain persistent and structured in a way that defies natural explanations, this could be a strong indication that we are dealing with something artificial. The possibility of 3I Atlas being an artificial object brings with it a host of ethical and philosophical questions. What if we are not alone in the universe and intelligent life has already reached out to explore the stars? What does that mean for humanity's place in the cosmos? How should we respond to the discovery of extraterrestrial technology if indeed that is what we are witnessing?
These questions go far beyond the realm of astronomy and touch upon the very nature of our existence. However, it's important to remember that even if 3I Atlas is not artificial, the discovery of such a massive and mysterious interstellar object is still a major breakthrough in our understanding of the universe. The fact that it has entered our solar system and presented us with such a baffling set of observations shows how little we truly know about the objects that inhabit interstellar space. Whether natural or artificial, 3I Atlas forces us to reconsider everything we thought we knew about comets, interstellar objects, and the potential for intelligent life beyond our planet. For now, astronomers will continue their work, gathering more data and refining their hypotheses. The answers to these questions may be closer than we think, and the discovery of 3I Atlas may represent a turning point in our understanding of the universe. Whether it's a natural phenomenon that pushes the boundaries of what we thought possible, or an artificial probe sent by an alien civilization, 3I Atlas has already left an indelible mark on the field of astronomy and on our collective imagination. As we move forward, the scientific community must remain vigilant in its pursuit of the truth behind 3I Atlas. While the idea of encountering extraterrestrial technology is fascinating, it is important to approach this potential discovery with caution and intellectual rigor. The path forward is one of careful observation and data analysis, with the possibility that future discoveries may either confirm or rule out the theories surrounding the object's origin. One of the most crucial aspects of this investigation will be the ability to conduct high-resolution spectroscopic studies of 3I Atlas as it continues to move through the solar system. By analyzing the spectrum of light emitted or reflected from the object, scientists can detect the chemical composition of its surface and its surrounding atmosphere. This data will provide vital clues as to whether the object is composed of materials consistent with natural comets, or if it contains elements and compounds that are unexpected in celestial bodies of its kind. Spectroscopy will also offer insights into the possible presence of unusual isotopic ratios, which could further suggest a non-natural origin. For example, if the isotopic ratios of elements like carbon or oxygen deviate significantly from what is typically found in comets, it would raise important questions about the processes that created 3I Atlas and its journey through the cosmos. The challenge lies in distinguishing between natural and artificial signatures. Without definitive proof, the question of its origins will remain open to interpretation. Additionally, tracking the motion of 3I Atlas will continue to be essential in determining the forces at play within its trajectory.
Cometary outgassing, typically causes small deviations in the trajectory of a comet, as the material that is expelled from the surface generates a push that alters the object's orbit. If 3I Atlas is indeed exhibiting such outgassing, we would expect to see measurable changes in its velocity. However, if the object's motion does not show these expected deviations, it may indicate that 3I Atlas is not experiencing outgassing, suggesting a different mechanism at work. In the coming months, astronomers will have the opportunity to gather more precise data on 3I Atlas as it continues its journey out of the solar system. Every observation, no matter how small, will contribute to the larger puzzle. The data gathered during this window of time could determine whether the object is a rare but natural phenomenon, or if it is, as some have suggested, an artificial probe sent by an extraterrestrial civilization. If it turns out that 3I Atlas is indeed an artificial object, the implications would be nothing short of transformative. Such a discovery would revolutionize our understanding of the cosmos and the potential for intelligent life beyond Earth. It would signal that we are not alone in the universe, and that other civilizations have already ventured into the stars, exploring and possibly communicating across vast distances. The discovery of 3I Atlas could be the first tangible evidence of extraterrestrial intelligence, igniting a new era of scientific exploration and philosophical contemplation. Even if 3I Atlas is eventually confirmed to be a natural object, its presence in our solar system serves as a reminder of the mysteries that still await us in the universe. The fact that such an object could travel across interstellar space and enter our solar system without our prior knowledge is both humbling and awe-inspiring. It reminds us how much there is still to learn about the vast expanse beyond our planet and the potential for discovery that lies within it. In the end, 3I Atlas challenges us to rethink our assumptions about the universe. Whether it is a comet or a spacecraft, its existence forces us to confront the unknown and to push the boundaries of our scientific knowledge. As more data becomes available, scientists will continue to refine their hypotheses and test their theories. The mystery of 3I Atlas may take years or even decades to unravel fully, but the journey of discovery has only just begun. As we await further observations, the next few months will be crucial in determining the true nature of 3I Atlas. One of the key upcoming milestones is the possibility of capturing high-resolution data as the object makes its closest approach to Earth, which will provide an invaluable opportunity for scientific examination.
With the right equipment, astronomers will be able to conduct a more in-depth analysis of 3I Atlas's surface, structure, and emissions, which may finally clarify whether it is a comet behaving in uncharted ways or something else entirely. In the coming weeks, the collaboration between professional astronomers and the ever-expanding network of amateur observers will play a significant role. Many amateur astronomers have already contributed valuable data, and their work continues to supplement the observations of larger telescopes. The power of citizen science in this context cannot be overstated. It ensures that we are not missing critical moments of observation, as these objects are often fleeting and the window for studying them can be narrow. As 3I Atlas recedes into the outer solar system, the urgency of capturing every moment becomes even more apparent. If 3I Atlas's trajectory is confirmed to be influenced by outgassing, further studies could help us understand how the material is being expelled from the object. While typical comets exhibit a scattering of gas and dust that forms a tail, the highly structured jets seen in 3I Atlas seem to defy this pattern. Whether these jets are the result of an unknown type of outgassing, electromagnetic forces, or even some other phenomenon remains to be seen. The physics required to explain the coherence of these jets over such vast distances suggests that the object is exhibiting behavior that stretches the boundaries of what we understand about comets and interstellar objects. As we gather more data, it will be essential to remain open-minded while also exercising scientific rigor. The quest to understand 3I Atlas may require us to question established models of cometary behavior and expand our framework to include new possibilities. Science progresses not by clinging to old ideas, but by adapting to new evidence and revising our theories accordingly. If 3I Atlas represents a new and unexplained phenomenon, it may require us to develop entirely new models to explain it, something that would be revolutionary in the field of astrophysics. On a broader scale, the presence of 3I Atlas in our solar system highlights the ongoing mystery of interstellar objects and the potential for future discoveries. The study of these objects is still in its infancy. Though we have made strides in detecting and analyzing interstellar visitors, we have barely begun to scratch the surface in terms of understanding their full range of behaviors and origins. The discovery of 3I Atlas, whether it turns out to be natural or artificial, opens a whole new realm of possibilities. The idea of a probe or spacecraft traveling across interstellar distances challenges our understanding of space travel.
The technology required to send a spacecraft on such a journey would be far beyond what we have today, and it would force us to reconsider our place in the universe. Are we truly alone, or have other civilizations already ventured out into the stars, observing the same mysteries that we're now uncovering? The possibility of finding evidence of extraterrestrial technology is both thrilling and daunting. It forces us to think about the broader implications of such a discovery. What would it mean for humanity to know that we are not alone in the universe? Would it prompt a global reassessment of our priorities, a new sense of unity, or perhaps a deepened sense of isolation? These philosophical questions are just as important as the scientific ones, as they touch upon the very essence of our existence and our role in the vast universe. Regardless of whether 3I Atlas is an artificial object or a rare natural phenomenon, the key takeaway is that the discovery of such an enigmatic object forces us to confront the unknown. It pushes the boundaries of our understanding and challenges the assumptions we have made about the universe. The future of space exploration will undoubtedly be shaped by the lessons we learn from studying objects like 3I Atlas, and the questions it raises will continue to inspire curiosity and wonder for generations to come. As the investigation into 3I Atlas progresses, we will likely find ourselves confronted with questions that extend beyond the realm of scientific analysis. The discovery of such an extraordinary object forces us to consider how much we truly know about the universe and whether we are prepared to accept the possibility of intelligent life beyond our planet. While the data gathered so far has been perplexing and intriguing, the true nature of 3I Atlas may take time to fully uncover. One of the most significant challenges will be distinguishing between natural and artificial explanations. If the object is truly artificial, then we must consider the technological capabilities to construct such an object capable of interstellar travel. The idea of an advanced civilization sending a probe or spacecraft on a journey spanning millions of years is not beyond the realm of possibility, but it does raise questions about the purpose of such a mission. Was 3I Atlas sent with the intention of exploring or observing distant stars and planets? Or is it simply a relic of a long-forgotten civilization drifting through space? While this idea may seem far-fetched to some, it is important to remember that history is full of unexpected discoveries. We once thought that Earth was the center of the universe, and we dismissed the possibility of intelligent life elsewhere. Yet, as we have explored space, our understanding of the cosmos has expanded exponentially.
The discovery of 3I Atlas could represent another turning point, a moment in history when we are forced to rethink our assumptions about the universe and our place within it. For now, the most pressing question remains: how do we proceed with the data we have? As the object moves further from the sun and fades from view, our ability to conduct detailed observations will diminish. However, we can still make the most of the remaining time by continuing to gather as much data as possible. The combination of ground-based telescopes, space-based observatories, and amateur astronomers all working together can provide a wealth of information. The more data we collect, the clearer the picture of 3I Atlas's true nature will become. In addition to the technological challenges of observing the object, there are also ethical considerations that come with the potential discovery of extraterrestrial technology. If 3I Atlas turns out to be an artificial object, what responsibility do we have as a species? Should we attempt to make contact with the civilization that created it? Or should we remain cautious, ensuring that we do not disrupt anything that could be far more advanced than we are? These are not questions that have easy answers, but they are ones that humanity will likely face if we continue to explore the possibility of extraterrestrial life. Moreover, the implications of finding evidence of an artificial object in our solar system would extend beyond the realm of science. It would spark a global conversation about humanity's place in the universe and challenge our assumptions about our role on Earth. How would societies around the world react to such a discovery? Would it unite humanity in the search for answers, or would it deepen divisions as different groups interpret the findings in their own ways? These are profound questions that go beyond the scope of scientific inquiry and touch upon the philosophical and societal implications of such a monumental discovery. As we await further observations, we must also consider how to communicate the results to the public. The story of 3I Atlas has already captured the imagination of millions, and as more data becomes available, it will be essential for scientists to communicate their findings clearly and responsibly. Given the potential for sensationalism, it is important to ensure that the information provided is grounded in evidence and that the public is given an honest assessment of the uncertainties involved. Regardless of the outcome, the discovery of 3I Atlas has already expanded our understanding of the universe. It has reminded us that there is still so much we do not know, and that the cosmos is full of mysteries waiting to be unraveled. Whether this object turns out to be a natural phenomenon, an artificial probe, or something else entirely, it has reignited our curiosity and reminded us of the vastness and complexity of the universe.
The answers to these questions may not come easily, but the journey of discovery has only just begun. As the investigation into 3I Atlas continues, it is clear that this object represents more than just a scientific curiosity. It has become a symbol of humanity's unyielding quest for knowledge. The very fact that such a mystery has been discovered within our solar system is a testament to the vast unknowns that still exist in the universe. Even if 3I Atlas turns out to be a natural phenomenon, its presence alone has sparked a profound shift in how we think about space and the potential for other life forms. This growing fascination with 3I Atlas underscores the importance of collaboration among astronomers, scientists, and even the general public. With the advent of advanced technologies, particularly in the field of telescopes and space-based instruments, we are now able to observe distant objects with a level of detail that was once unimaginable. The role of amateur astronomers, who have contributed significantly to this discovery, cannot be overstated. Their passion and perseverance have provided crucial data that may prove to be the key to unlocking the mystery of 3I Atlas. However, as much as our tools have advanced, the interpretation of this data requires careful consideration. While the data gathered from telescopes, space missions, and even citizen science are invaluable, it is essential to approach these findings with scientific skepticism.
This is especially true when dealing with an object that behaves in such an unconventional manner. As we continue to collect more information, the question remains whether our current understanding of cometary and interstellar objects is complete, or whether we need to expand our knowledge to accommodate new, unexpected behaviors. For now, the scientific community must remain open to all possibilities. The data may reveal that 3I Atlas is indeed a natural object, albeit one with properties that we do not fully understand. Or it may point to something far more profound, a message from the stars, a probe, or a relic from a distant civilization. The only way forward is to gather more evidence and continue testing our hypotheses. In doing so, we may not only solve the mystery of 3I Atlas, but also open the door to new discoveries that could change the course of human history. The future of space exploration is undoubtedly bright, but it is also filled with uncertainty. As we venture further into the unknown, we must continue to question what we know and remain willing to revise our theories as new data emerge. The discovery of 3I Atlas has shown us that the universe is full of surprises, and it is a reminder that no matter how much we learn, there will always be more to explore.
In the coming years, astronomers and scientists will continue to study this object, and the answers they uncover could revolutionize our understanding of the cosmos. Whether it is a natural object or an artifact of alien technology, 3I Atlas will undoubtedly be remembered as one of the most extraordinary discoveries in the history of astronomy. It represents a turning point in our exploration of the universe, one that may forever alter our perspective on life beyond Earth. As we continue to observe 3I Atlas and study its behavior, we should also remain mindful of the broader implications of this discovery. The search for extraterrestrial life and the study of interstellar objects have only just begun, and 3I Atlas may be the first of many extraordinary objects to pass through our solar system. The next few years could bring more answers or lead us down entirely new paths of inquiry. Either way, the journey of discovery continues, and the universe has much more to reveal. Looking ahead, the case of 3I Atlas highlights the unpredictability of space exploration. As we continue to refine our tools and techniques for observing distant objects, there will always be the potential for unexpected surprises. The universe is vast, and as we venture further into its depths, it's clear that the questions we're asking today may soon be overshadowed by even greater mysteries. One of the most exciting prospects is that 3I Atlas could serve as a catalyst for new approaches in astrophysical research. If it turns out to be a comet or interstellar object that simply defies current scientific explanations, it could prompt a reassessment of the fundamental principles of cometary behavior and interstellar object dynamics. Such a breakthrough would push the boundaries of our knowledge and spark a new era of discovery, challenging our assumptions and expanding our understanding of space. However, the importance of collaboration across disciplines cannot be overstated. As we seek answers, it's essential that scientists from various fields – astronomy, physics, chemistry, and even engineering – work together to uncover the truth behind 3I Atlas. Each discipline offers a unique perspective that can contribute to solving the puzzle. For example, the study of cosmic rays, the physics of solar winds, and even materials science could provide insights into how the jets of 3I Atlas remain so coherent and massive. It is only by embracing a multidisciplinary approach that we'll be able to answer the most pressing questions about this mysterious object. In addition to the collaboration among scientists, there's also the role of public interest in space exploration. The case of 3I Atlas has captured the public's imagination, reminding us how much we are drawn to the unknown. This interest can be a powerful force, pushing governments, private organizations, and research institutions to allocate more resources toward space exploration and related scientific fields.
As more discoveries like 3I Atlas are made, we can expect the desire for knowledge to continue to grow, creating a more robust support system for scientific inquiry.
Despite the excitement, there are still significant challenges ahead. The journey to understanding 3I Atlas requires careful and sustained observation. With each passing day, the object moves further away, making it more difficult to capture high-resolution data. As we approach the limits of our observational capabilities, the risk of losing valuable opportunities for detailed study grows. However, this challenge also serves as a reminder of the importance of timely and coordinated efforts in space research. The work of astronomers, both professional and amateur, is crucial in ensuring that we do not miss the fleeting moments that could provide the answers we seek. In a broader sense, 3I Atlas represents a symbol of humanity's ongoing search for knowledge. The object serves as a reminder that our understanding of the universe is still incomplete and that there is so much left to explore. Whether 3I Atlas proves to be a rare natural phenomenon or an artifact of an advanced civilization, the mystery surrounding it is a testament to the endless possibilities that await us in the cosmos. In the coming years, as we continue to monitor 3I Atlas and potentially discover other interstellar visitors, we may find ourselves closer to answers than we ever imagined. The ongoing study of these objects, coupled with advancements in technology and global collaboration, will no doubt yield groundbreaking discoveries. With each new finding, we inch closer to understanding not just the objects that pass through our solar system, but also the very nature of the universe itself. Whatever the outcome of the investigation into 3I Atlas, one thing is certain: the future of space exploration is brimming with potential. The discoveries made in the coming decades will shape how we view our place in the cosmos and our relationship to the universe beyond Earth. And who knows, perhaps 3I Atlas is just the beginning of a long journey into the unknown, a journey that will uncover even more astonishing truths and challenge the limits of human knowledge. As we stand on the cusp of future discoveries, the story of 3I Atlas may eventually become a turning point in our approach to space exploration. It represents more than just an isolated anomaly. It serves as a reflection of the ongoing evolution of scientific inquiry. The excitement surrounding 3I Atlas is a reminder of the human spirit of exploration, the desire to seek answers to questions that are often just beyond our reach. In the years to come, 3I Atlas will likely be remembered as one of the most significant interstellar objects to pass through our solar system, sparking new research and inspiring new generations of astronomers and scientists.
If the object is confirmed to be artificial, it could inspire humanity to think in bold new ways about space exploration. The idea that another civilization might be capable of sending probes or spacecraft across the vast distances of interstellar space would change our understanding of technology and our place in the universe. But even if 3I Atlas is eventually understood to be a natural phenomenon, it would still challenge us to think outside the box. The sheer scale of its jets, the rapid expansion, and the strange alignment of its trajectory would all represent a new frontier in our study of comets and interstellar objects. In either case, the discovery of 3I Atlas serves as a catalyst for pushing the boundaries of our scientific models and broadening our horizons. Looking to the future, the importance of international cooperation in space exploration cannot be overstated. The study of 3I Atlas is a global endeavor, with astronomers and scientists from all over the world working together to unravel its mystery. As technology continues to advance, the capabilities of our telescopes, both ground-based and space-based, will only improve. With these advancements, we will be better equipped to observe distant objects, monitor their trajectories, and analyze their composition in ever greater detail. But beyond the technological aspects, the collaboration between scientists and the public will continue to be key. The role of amateur astronomers and citizen scientists will grow even more vital in the years ahead. As we look to explore deeper into the cosmos, the democratization of science will ensure that no discovery goes unnoticed.
The enthusiasm and dedication of individuals around the world will help ensure that humanity's curiosity about the universe remains unquenched. The lessons learned from studying 3I Atlas will likely extend far beyond this single object. Our understanding of interstellar objects and our ability to detect and study them will improve dramatically as a result of this investigation. This could lead to even more discoveries in the future, including the detection of additional interstellar visitors that might offer new insights into the nature of space, the origins of our solar system, and the potential for life elsewhere in the universe. In the end, 3I Atlas is a reminder of the vast unknowns that still await us in the cosmos. It highlights the importance of continuing to ask questions and challenge our assumptions. With each new discovery, we move closer to answering some of humanity's oldest and most profound questions. Are we alone in the universe? How did the solar system come to be? What lies beyond the stars? The search for answers will continue, and whether 3I Atlas turns out to be a natural object, an artifact of an alien civilization, or something else entirely, its legacy will be one of expanding the boundaries of human knowledge.
The object has already captured our collective imagination, and its story will likely inspire many more generations to come. As we continue to explore the cosmos, we are reminded that in the vastness of space, there are still countless mysteries waiting to be uncovered. As we move forward into the uncharted territory that 3I Atlas has opened, the broader implications of this discovery cannot be ignored. It has already reshaped our approach to understanding celestial bodies that pass through our solar system. More importantly, it has reminded us that the universe is filled with anomalies, and that our existing scientific models may need to be reevaluated to account for the unexpected. Every breakthrough like this pushes us to refine our methods and challenge the limitations of our current knowledge, propelling humanity further along the path of scientific discovery. One of the most exciting aspects of this journey is that 3I Atlas, whether it turns out to be a comet or an artificial object, is merely the beginning. We may be on the cusp of a new era in space exploration, one in which interstellar objects become more common and our ability to study them improves dramatically. The possibility that more interstellar visitors could be on their way to our solar system challenges our assumptions about the nature of our neighborhood in the Milky Way. What if 3I Atlas is just one of many objects traveling through our cosmic backyard? Each new object we discover could hold key insights into the formation of stars, planets, and perhaps even life beyond Earth. Furthermore, the technological advancements that have allowed us to study 3I Atlas in such detail are only the beginning of what will become possible in the near future. As our telescopes continue to grow in power, our ability to observe and analyze distant objects will reach unprecedented levels. Space telescopes like the James Webb Space Telescope, or JWST, and ground-based observatories, such as the European Extremely Large Telescope, or ELT, will provide a deeper understanding of the universe, enabling us to detect and study interstellar objects as never before. These advancements will not only enhance our knowledge of comets and asteroids, but also pave the way for the discovery of entirely new types of celestial bodies. The possibility that 3I Atlas could be the first evidence of extraterrestrial technology, while still speculative, is one that will continue to spark debate for years to come. If future observations support the hypothesis that it is an artificial object, the implications will extend far beyond the scientific community. The discovery of technology from another civilization would force humanity to reconsider our place in the universe. It would prompt an urgent reassessment of our technological capabilities, our understanding of the cosmos, and our approach to future space exploration.
The prospect of interstellar travel, once considered the stuff of science fiction, might move closer to reality. As scientists continue to analyze 3I Atlas, they are also setting the stage for a broader conversation about the search for extraterrestrial intelligence, or SETI. This discovery, if proven to be artificial, would raise fundamental questions about how we look for signs of life beyond Earth. Should we focus on signals from distant stars, or should we also be looking for physical evidence, such as objects passing through our solar system? The search for extraterrestrial intelligence may need to expand, incorporating new strategies and technologies that go beyond the traditional methods of listening for radio signals. Ultimately, whether 3I Atlas proves to be a natural object or an artificial one, its discovery will have lasting consequences for the scientific community and society as a whole. The questions it raises about the nature of life in the universe, the possibilities of interstellar travel, and the boundaries of human knowledge will continue to inspire generations of scientists, engineers, and thinkers. It is a reminder that the universe is vast, full of surprises, and still largely unexplored, leaving plenty of room for discovery. As we continue to study this object, we should remain open-minded, ready to adjust our theories, and willing to explore every possibility. The pursuit of knowledge is a continuous journey, and each discovery, whether expected or unexpected, serves to propel us forward into the unknown. The legacy of 3I Atlas may not only change the way we view our solar system, but also ignite a new wave of curiosity and exploration that will shape the future of space science for decades to come. Looking further ahead, the story of 3I Atlas may mark a new chapter in our search for answers about life beyond Earth. If 3I Atlas turns out to be an artificial object, it could change not only how we think about extraterrestrial intelligence, but also how we approach the broader search for life in the universe. The discovery would encourage a shift in our search strategies, prompting us to look beyond the radio signals and electromagnetic waves we have traditionally relied on. We may soon realize that objects like 3I Atlas are just the tip of the iceberg, and that there are many more discoveries to be made in the depths of interstellar space. The role of technology in this exploration cannot be overstated. With advancements in space-based telescopes, artificial intelligence, and data processing, our ability to analyze and interpret distant objects will only continue to improve. These technologies will provide us with the tools we need to detect, track, and study interstellar visitors with an unprecedented level of precision.
As our capabilities grow, we will be better positioned to understand the origins of objects like 3I Atlas, and perhaps discover others like it, each with its own unique story to tell about the cosmos. If 3I Atlas is indeed an artificial object, one of the most pressing questions will be whether it was deliberately sent on its journey, or if it is simply a piece of debris from a distant civilization drifting through space. Could it be a probe sent to gather data, much like the probes we have sent to explore other planets? Or could it be a relic, long abandoned and forgotten by its creators? The answers to these questions would provide profound insights into the nature of interstellar civilizations, their technologies, and their motivations. It would challenge us to think beyond our current understanding of space exploration and consider what it might be like to live in a universe where intelligent life is not confined to Earth alone. However, even if 3I Atlas is not artificial, it is still a remarkable object that forces us to reconsider our current models of space and time. Its behavior challenges the fundamental laws of cometary physics, and it is an object that demands further study. Whether its massive jets and strange trajectory are the result of unknown natural processes, or are simply a rare example of cosmic phenomena that we have yet to fully understand, it represents a unique opportunity to expand our knowledge of the universe. As 3i Atlas continues its journey beyond our solar system, it is clear that this discovery will have lasting effects on the field of astronomy. Future generations of scientists will look back on this moment as a pivotal point in our understanding of interstellar objects. Whether it turns out to be a comet, an artificial probe, or something entirely new, the impact of this discovery will reverberate through the scientific community and beyond, igniting further exploration and inspiring curiosity about the unknown corners of the universe. In the end, the true legacy of 3i Atlas may not lie in its classification as a comet or a spacecraft, but in the way it has transformed our thinking about the cosmos. It has sparked a global conversation about the possibilities of life beyond Earth, about the potential for advanced civilizations, and about the limits of our understanding. It has reminded us that no matter how much we learn, the universe still has many secrets waiting to be uncovered. As we continue to observe 3i Atlas and await more data, one thing is certain. This object and the questions it raises will stay with us for years to come. Its discovery has already changed the way we view space, and in the future, it may lead to new and even more astonishing discoveries. The journey of exploration is never truly over, and the universe continues to reveal its mysteries, one object at a time.
As humanity continues its quest for understanding the universe, 3i Atlas serves as a powerful reminder that we are only scratching the surface of what's out there. The object has not only ignited a wave of scientific curiosity, but has also raised existential questions about the nature of life and intelligence beyond Earth. Whether we ultimately discover that 3i Atlas is a natural phenomenon or an artificial object, the journey of exploration will have lasting impacts, reshaping how we view our place in the cosmos. Looking forward, the future of space exploration will undoubtedly be influenced by the findings related to 3i Atlas. As we develop better tools for observing and analyzing distant objects, we will likely encounter more interstellar visitors that challenge our existing models. These discoveries will fuel further innovation in space technologies, driving advancements in telescope design, spacecraft engineering, and data processing. The ability to track and study objects that come from beyond our solar system will unlock new avenues for understanding the history of our galaxy, the dynamics of interstellar space, and the potential for extraterrestrial life. The possibility that 3i Atlas is an artificial object, despite still being speculative, opens up new fields of inquiry. If proven to be a probe or spacecraft, it would fundamentally shift how we think about space exploration. The idea of extraterrestrial civilizations sending probes across vast distances would require us to rethink the limits of technological innovation, both for the civilizations that created these probes and for our own future. It would spark a revolution in how we approach space travel, encouraging humanity to set its sights on the stars with renewed ambition and determination.
By challenging our understanding, 3i Atlas could propel the field of astronomy into new frontiers where even more remarkable discoveries await. Moreover, the discovery of 3i Atlas has highlighted the importance of global collaboration in space exploration. The object's enigmatic nature has brought together scientists from all over the world, working in concert to unravel its mystery. This spirit of cooperation is vital as we face future challenges in space exploration. In an era of increasingly complex and far-reaching scientific endeavors, sharing data, resources, and expertise across borders will be essential to advancing our collective understanding of the universe. Ultimately, the legacy of 3i Atlas will extend far beyond its classification as a comet or a potential spacecraft.
It will stand as a beacon of the unknown, a symbol of humanity's unquenchable curiosity and our drive to explore the cosmos. The mystery it presents will continue to inspire generations of scientists, engineers, and explorers to seek out answers to the greatest questions about life, the universe, and everything in between. With every new discovery, we move closer to understanding the true nature of the universe, one that is vast, mysterious, and full of surprises. The story of 3I Atlas is still unfolding, but no matter the final answer, it will forever be remembered as one of the most intriguing and thought-provoking events in the history of astronomy. The search for answers may be long and uncertain, but the journey itself is what makes the quest for knowledge so exciting, and 3I Atlas will undoubtedly be a pivotal chapter in that ongoing exploration. As we look to the future, the discovery of 3I Atlas stands as a testament to the unpredictable nature of space exploration. It shows us that the universe is full of wonders that defy our expectations, and sometimes the most extraordinary findings come from the least expected sources. Whether or not 3I Atlas turns out to be artificial, it has already sparked a revolution in how we view the cosmos and our place within it. The ongoing research into 3I Atlas will not only affect the field of astronomy, but also influence the broader scientific landscape. The study of interstellar objects, whether they are comets, asteroids, or probes, opens up a whole new field of research that could have profound implications for many disciplines. For example, by analyzing the composition and behavior of objects like 3I Atlas, scientists may learn more about the origins of the solar system, the nature of interstellar space, and even the potential for life elsewhere in the galaxy. These discoveries could bring us closer to understanding the fundamental building blocks of the universe itself. Furthermore, the exploration of interstellar objects may soon become an essential part of space exploration efforts. As technology improves, the ability to send spacecraft beyond our solar system is becoming a more realistic prospect.
Missions like NASA's recently proposed Breakthrough Starshot project, which aims to send small, lightweight probes to nearby star systems, are the first steps in what could eventually lead to humanity's ability to explore the stars. The discovery of objects like 3I Atlas could play a pivotal role in shaping the goals and methods of these future missions. The mystery of 3I Atlas also speaks to the importance of maintaining an open mind in scientific inquiry. It serves as a reminder that even the most well-established theories can be upended by new discoveries. If 3I Atlas turns out to be a completely new type of object, or even something artificially made, it would highlight the need for flexibility in our scientific models. As we continue to explore the universe, it's crucial that we remain willing to adapt our theories and embrace new ideas, no matter how unconventional they may seem at first. In many ways, 3I Atlas embodies the spirit of discovery that drives humanity's exploration of the cosmos. The quest for knowledge has always been about venturing into the unknown, questioning what we know, and challenging the boundaries of human understanding. The mysteries surrounding 3I Atlas remind us that the universe is vast and still largely unexplored, offering endless opportunities for discovery and adventure. As we continue to study 3I Atlas and its potential implications, one thing is clear: the search for answers will not stop with this one object. In fact, 3I Atlas may be the first of many extraordinary discoveries that will unfold over the coming years. With each new interstellar object that we encounter, our knowledge of the cosmos will grow, and we will be one step closer to answering some of the most fundamental questions about the universe. Are we truly alone? What lies beyond our solar system? And perhaps most importantly, how can we, as a species, continue to explore the unknown and uncover the secrets of the cosmos? In the end, 3I Atlas may not provide all the answers, but its legacy will lie in the inspiration it provides for future generations of scientists, explorers, and dreamers. It is a reminder that the journey of discovery is never truly complete. The universe remains full of mysteries, And as long as we continue to seek the unknown, there will always be new frontiers to explore. As we delve deeper into the study of 3I Atlas, we must also consider the broader implications for humanity's understanding of the universe. This discovery may be the first of many interstellar objects that pass through our solar system, each of them holding its own unique mysteries. The increasing frequency of these encounters could drive a new wave of space exploration and innovation in technology. If 3I Atlas is truly a harbinger of interstellar objects to come, we may soon find ourselves facing even more challenging and exciting questions. One of the most exciting prospects is that the study of 3I Atlas could redefine our understanding of what constitutes a comet or an asteroid. The behaviors and characteristics observed in this object are unlike anything we've seen in our previous interstellar visitors. As our tools and observational techniques advance, we will gain the ability to study these objects in greater detail, potentially discovering new types of celestial bodies that we had previously never imagined. It is only by continually testing our theories and adapting to new discoveries that we will begin to piece together the true nature of the universe around us. The potential for 3I Atlas to be an artificial object opens up a host of possibilities. While the evidence for this theory remains speculative, the very thought of extraterrestrial technology entering our solar system forces us to reconsider our approach to space exploration. If 3I Atlas is indeed a probe or spacecraft, it would be the first direct evidence of intelligent life beyond Earth, sparking a revolution in our understanding of technology and space travel. It would prompt humanity to reassess its role in the cosmos and our relationship with other possible civilizations, especially ones that may have advanced far beyond us. Regardless of the outcome, the legacy of 3I Atlas will likely extend far beyond its classification as a comet or artificial object. The questions it has raised will inspire generations of scientists, astronomers, and philosophers to rethink their assumptions about space, life, and our place in the universe. Whether it leads to new theories about interstellar travel, the possibility of life beyond Earth, or the very nature of celestial bodies, 3I Atlas has already made an indelible mark on the scientific community. As we continue to monitor and study 3I Atlas, we should remain open to the possibility that this is just the beginning. More interstellar objects will likely pass through our solar system in the future, and each one will offer us a new opportunity to expand our knowledge. The future of space exploration is bright, and 3I Atlas is a reminder that we have only begun to scratch the surface of the cosmos. With every discovery, we move one step closer to understanding the vast and mysterious universe that surrounds us. The potential implications of 3I Atlas are not confined to the realm of astronomy alone. This discovery has the power to ignite debates in many other fields, from philosophy to ethics to technology. If 3I Atlas turns out to be an artificial object, the implications would not only redefine the search for extraterrestrial life, but also force us to confront questions about the very nature of intelligence and the future of humanity. How would we, as a species, respond to the realization that we are not the only intelligent beings in the universe? What responsibilities would we have toward understanding and possibly interacting with other civilizations, especially ones that may have advanced far beyond us?
In addition to the philosophical and ethical questions, the technological advancements that may arise from studying 3I Atlas are immense. If it turns out that this object is a spacecraft or probe, it would imply that there are technologies capable of interstellar travel, something humanity has yet to achieve. The technological breakthroughs that would allow a civilization to send probes across vast interstellar distances would be monumental. This could drive humanity to develop new methods of propulsion, communication, and space travel, pushing the boundaries of what we think is possible. If we can learn even a fraction of the technology that may be embedded within 3I Atlas, it could propel human space exploration into a new era. On the other hand, if 3I Atlas is a natural object, whether a comet, asteroid, or something yet to be classified, it would still have profound implications for our understanding of interstellar space.
The object's size, trajectory, and behavior challenge our existing models of comets and asteroids. It has already forced astronomers to reconsider their assumptions about the dynamics of such bodies and how they travel across space. In this case, 3I Atlas would serve as a reminder that the universe is far more complex and unpredictable than we can imagine, and that our current knowledge is always subject to revision and expansion. No matter the outcome, 3I Atlas has demonstrated the incredible potential of space exploration. It has shown us that there is still so much to learn about the universe, and that even the smallest discoveries can have far-reaching consequences. This is just the beginning of what may turn out to be a much broader journey of discovery, one that could open up entirely new fields of scientific inquiry and lead to breakthroughs that we can scarcely anticipate. As we continue to study 3I Atlas and other interstellar objects, we are not only advancing our understanding of space, we are reshaping our place in it. The coming years will undoubtedly reveal more about 3I Atlas as new data and observations continue to be collected. Whether it turns out to be a comet, a probe, or something else entirely, the journey to uncover its secrets is sure to captivate scientists, the public, and future generations. And in the process, we will continue to learn about the mysteries of the cosmos, pushing the boundaries of human knowledge and our understanding of the universe. Looking ahead, the study of 3I Atlas offers an opportunity to revolutionize our understanding of space and technology. Regardless of the object's true nature, it is a reminder that the universe holds mysteries far beyond our current knowledge. With each passing year, the tools we use to explore space become more advanced, and with them, our ability to understand the distant reaches of the cosmos. 3I Atlas represents a challenge that will push scientists to innovate and think beyond the conventional.
In the coming decades, humanity's ability to explore interstellar space will continue to grow. Proposals for missions to other star systems, such as the Breakthrough Starshot initiative, aim to send tiny probes to nearby stars, and these technologies could open up new realms of possibility. The investigation of objects like 3I Atlas will likely play a central role in these endeavors, offering valuable insights into the practicalities of interstellar travel and the objects that inhabit space beyond our solar system. Furthermore, as space exploration continues to evolve, international collaboration will be key to making these advances. The study of 3I Atlas is not just the work of a single nation or a group of researchers. It is a global effort that spans countries and cultures. This collective approach will undoubtedly be crucial as humanity works to understand the deeper questions of existence and to venture further into the unknown. If 3I Atlas is only one example of many interstellar objects, our ability to detect, study, and understand them will shape the future of space exploration. In the end, the legacy of 3I Atlas will not just be in the data we collect or the discoveries we make about the object itself. It will inspire us to reach further, to ask bigger questions, and to pursue the unknown with an open mind. Whether we uncover new insights into the origins of the solar system, learn about the possibility of life beyond Earth, or develop technologies that make interstellar travel possible, 3I Atlas will have already achieved something profound. It will have reminded humanity that the universe is still full of wonders waiting to be explored. The study of 3I Atlas, no matter the final conclusion about its nature, will continue to fuel our curiosity and expand the boundaries of human knowledge. Its discovery has not only opened a window into the world of interstellar objects, but has also forced us to confront the limitations of our current scientific understanding. We have come to realize that the universe is far more complex than we ever imagined, and our exploration is just beginning. In the coming years, as more interstellar objects are discovered, it will become increasingly important to develop new methodologies and technologies to study these fleeting visitors. As our observational tools improve, so too will our ability to gather data on these objects in greater detail. Whether it's through advanced telescopes, spacecraft, or even new AI-driven methods for processing vast amounts of space data.
The development of these technologies will be crucial for answering the many questions raised by 3I Atlas and other objects like it. As we study these interstellar visitors, we may uncover information that has the potential to transform other areas of science, such as astrophysics, material science, and even the search for extraterrestrial life.
For example, the composition of objects like 3I Atlas could tell us more about the building blocks of planets and stars, the formation of galaxies, or even how life could exist in other parts of the universe. These revelations could help us refine our models of planetary formation and the conditions necessary for life to develop elsewhere. Moreover, the study of 3I Atlas could shed light on the broader dynamics of the universe. By examining how such objects travel through space, how they interact with different cosmic environments, and how they impact the solar system, we will learn more about the processes that govern the evolution of galaxies and star systems. These findings could have far-reaching implications for our understanding of space, helping us uncover not only the history of our own solar system, but also the broader narrative of the universe itself. In the long run, 3I Atlas may inspire a new generation of scientists, engineers, and explorers to dedicate themselves to unraveling the mysteries of the cosmos. It could spark new initiatives, encourage further collaboration across scientific disciplines, and lead to innovative approaches to space exploration. The quest to understand the object's origin and behavior could be the catalyst for breakthroughs in technology and research that extend far beyond this one discovery. No matter what we ultimately learn about 3I Atlas, it will remain a symbol of humanity's unending curiosity and drive to explore the unknown. It serves as a reminder that the universe is vast, full of unknowns and unexpected wonders, and that our search for answers is far from over. The discovery of 3I Atlas has ignited a new era of exploration, and its legacy will likely shape the future of space science for many years to come.